So I've drawn two triangles here, and there's 30 degrees between the slopey blue and the horizontal green in both cases. And you can see that the two triangles are of dramatically different size, but yet that same angle exists between the blue and the green. I can make that triangle any size I like, so long as I blow it up in the same proportions that I've got here. That same angle of 30 degrees will be produced. The value of the angle comes from the ratio of the sides, not the absolute values of the sides. So let's have a look at the minimum requirements we need to form those self-same triangles. Well, so long as there's a right angle between the vertical and the green, and I've got the length of the vertical and the green, I've effectively got the two triangles, because all I've got to do is put in the slopey blue lines, and I've got the two triangles we started with. So two side lengths will give us the triangle. So these triangles actually don't need all the information we've got displayed here. We don't need to know the length of all three sides and the angles. They all interrelate. One forms from the other. So what ratios have we got? Well, that 30 degrees can be defined by the ratio of red to blue, or from green to blue, or from red to green. Now, clearly we can't keep using these colours. We have to define terms that, from the 30-degree angle point of view, define what sides we mean. Well, if you were that 30-degree angle and you looked out, what would be opposite you? Well, it would be the red side. So a very good name for the red side would be opposite. Okay, again, if you were at that 30-degree angle and you looked to the side that was alongside, it's the green side, we need a name to define the side which is alongside. And we use another term that does mean alongside, and it's adjacent. Now, what about this side? What about the blue side? Well, the blue side is the longest side. And that you've probably met before as a term when we're dealing with triangles, and it's called the hypotenuse. So we can lose our colours and replace them with the more technical terms of opposite, adjacent, and a hypotenuse. So here's where some complication comes in. Three more terms to understand. That ratio of red to blue, which we now define as the opposite side from the angle divided by the longest side, the hypotenuse, we give it the name sine. It's the sine of the angle. Similarly, green over blue, which we've more accurately called the adjacent over the hypotenuse, we give the name cosine. And red over green, now defined in terms of the opposite divided by the adjacent, we give it the term tangent. So we've got three different definitions of how we find an angle in a triangle from knowing lengths of other sides. So from the values of the lengths of the sides, we can go to the angle, or indeed if we know the angle, we can go to the value of the sides.